Hello, welcome back to physics class. In this video, we're taking a look at phase, power and power factor, resonance in RLC series circuit. So let's get started. In the first case, have phase. What is phase? It is the state of vibration of a periodically varying system at a particular time. That is what phase is. And in our AC circuit, you remember that the voltage V is equal to V naught sine omega t if there is no phase difference, that if there is no inductor nor capacitor in the system. Omega t here simply represents our phase angle. That is phase angle equals omega t. Okay, so that's the phase angle omega t. So in relation to what we've done previously, our phase angle can be evaluated for a system that has inductor and capacitance as well as resistance. That is for RLC series circuit. Phase angle can be gotten from the tan of phase angle phi. This is our phase angle phi is simply equal to x over r, where x simply stands for XL minus XC. And remember, if this is a system that has only inductor or only capacitance, you choose only one out of the two of them. So this is our formula for phase angle. If you have the value of this, subtract them, divide by the value of resistance, taking the arctan, you give us the phase angle. So, and let's not forget that for a resistor in an AC circuit, the phase angle is equal to 0, and for inductor in an AC circuit, yes, for inductor in an AC circuit, we have a phase difference of what? Pi by 2, where we say that in this system, the current lags the voltage by the angle pi by 2. In the previous video, they are there, you can check them to have a full understanding. We said that in the first or second video, something like that. So this also implies that we can say that our phase angle, tan of phase angle, is equal to the voltage through the inductor minus voltage through the capacitor all over voltage through the resistor, in case you are giving voltages instead of the reactance. It's still the same equation. And generally, we consider the total voltage in the system, V squared, is equal to the voltage through the resistor square plus the voltage through the inductor minus voltage through the capacitor squared. So this is what we have for phase. This is not part of phase though, you just have to recall the last one. Now let's quickly go for power. Yes, before moving to power, please note that you can say XC minus XL. It strictly depends on which one is greater. It cannot be negative. You must not have negative. Understand? So that is, if you subtract and you're having negative, it means that what? If XL is greater than XC, it means that the current is lagging voltage. And if XC is greater than what? XL, it means that what? The voltage is what? Is leading the current. Yes. If XL greater than XC, current lags voltage. XC greater than XL, current leads voltage. So, having done this, let's get on to the next one, which is power. Power and power factor. As we recall, power from electrical circuit is equal to IV. But in this case, since we have phase for an RLC circuit, we multiply by the cos of what? The phase angle, cosine of phase angle. So this is the power of the system. Yes. And if this is a resistor only system, we can say that power is simply equal to I square R. Remember, you cannot use this for this one because this is not a resistor. The voltage just simply means the voltage you're having here. Then power factor simply means the cosine of phi, and cosine of phi is given by R all over impedance C, which is what? Resistance over impedance. This is what we call power factor, resistance over impedance. So then the last one we'll take a look at is resonance. What is resonance? Yes, quickly brainstorm. I've got you covered if you don't know or if you can't recall. Resonance is said to occur in an AC circuit when the maximum current is obtained. Whenever you have maximum current, we say that we have what? A resonance. Yes, at the point where you obtain the maximum current, that is the point of resonance in an AC circuit. So, at resonance, the important thing to know is that at resonance, the inductive reactance equal capacitive reactance. That is the only thing you have to know. And the frequency at resonance, frequency is known as resonance frequency, F naught. We call it what? Resonance frequency. So, as such, if XL equal to XC, it simply means